Stan Gibilisco here with installment number 8 in the Logarithms in a Nutshell tutorial sequence. We've learned now about base 10 logarithms, and we've also learned what the natural logarithm base, that strange number, that strange irrational number called e, is approximately 2.71828, and the number which serves as a logarithm base, along with 10, which also serves as a logarithm base. We've learned about the base 10 or common logarithms so far. If we graph in relative terms the logarithm function, where x goes out along the horizontal axis to the right, and the logarithm of x, base 10 logarithm, or any base, any reasonable base, e or 10, we're going to get a curve that looks like this. The logarithm of for any either e or 10 base of 1 is always going to be 0. It's going to increase positively, but more and more slowly as we go out that way, and then it blows up negatively as we approach x equals 0, so that the logarithm of 0 is not defined in the set of real numbers, nor are any logarithms of negative numbers defined in the set of real numbers. So 10 to the 0th equals 1. That means that the base 10 logarithm of 1 equals 0. The base 10 logarithm of 1 equals 0. E to the 0th also equals 1. The base e logarithm of 1 also equals 0. So let's just change this now from log, meaning common log or base 10 log, to ln. Usually, for some reason, they use a lowercase l. The base e logarithm, okay, the base e logarithm of 1 is 0. Now, let's just take an example that I worked out on my calculator. I discovered that e squared is approximately equal to 7.38906. 7.38906. Technically, we should use a wavy equal sign because this is an irrational number. That's an irrational number. We square that, we get an irrational number. What this means is that the base e logarithm of this thing is equal to 2. In other words, the logarithm of 7.38906 is approximately equal to 2, or if we use that irrational number itself, it's exactly equal to 2. 7.38906 would be somewhere out here on this graph, so that would be equal to 2. Let's just put that right up here, okay? That's this value right here. We take that over to this axis. That's equal to 2. If we put e somewhere right here, e to the 1 equals e. So the base e logarithm of e equals 1. The natural logarithm of e equals 1. So we can graph it like this. Now, I also took e to the minus 1 in my handy dandy calculator and got 0.367879. 0.367879. 0.879. Again, approximately, because that's 1 over e. The reciprocal of an irrational number will turn out irrational. That means that the natural logarithm of this number is equal to -1. The base e logarithm of that is -1. So, if we put that value, would be right about there on the graph. And we go down to our curve, it's going to correspond to -1. Now you can see that the curve that we get when we graph the natural logarithm function, or the base e logarithm function, it has the same general contour, the same general shape as the base 10 logarithm does, except instead of e, if we use the base 10 logarithm, this would be 10. This value out here would be 100, and this value right here would be 1/10. But otherwise, the curve has the same general contour. So if we're talking about the logarithm, the natural logarithm of x, we can also write that as log base e of x. And in fact, sometimes you will see it written that way. Now, natural logarithms, of course, arise in physics and engineering, in certain situations that crop up in nature. That is a more natural logarithm than the base 10 logarithm is. There's just something about this number e, as we learned in the previous video, that makes it a very special and unique number. That is why the natural logarithm came into existence and why it plays such an important role in natural sciences and engineering. So, natural logarithm means we use a base of e, where once again e equals approximately 2.71828. The natural logarithm of 0 or any negative number is undefined, just as is the case with the common or base 10 logarithm. Generally, you will rarely hear of logarithms to any other base besides 10 or e. If we talk about the common logarithm, again, that is the base 10. So now you know about common and natural logarithms, and that's pretty much it. You can work now with anti-logarithms, also known as exponential functions, and depending upon which way the winds blow and what phase the moon might happen to be in, pretty soon you might see me doing some exponential function videos as well. But for now, so long until whatever comes down the road next. Stan Gibilisco signing off.